Hello everyone, I am Harshith from Scientific College of Engineering. Today I am here to present the topic Consecutive Integer Checking Algorithm for GCD. So let us see the introduction to the consecutive checking algorithm for GCD. The consecutive checking algorithm is a simple and intuitive method for finding the greatest common divisor of the two integers. It involves systematically checking consecutive integers as potential divisors. Understanding the concept of greatest common divisor, which is GCD. The GCD of two integers is the largest positive integer that divides both of them without leaving a remainder. For example, the GCD of 12 and 18 is 6. Definition: the largest number that divides two numbers without a remainder. The example is the GCD of 12 and 18 is 6, and 6 is the largest number that divides both 12 and 18 without leaving a remainder. Step-by-step explanation of the consecutive checking algorithm. The algorithm works by iterating through integers from 1 up to the smaller of the two input integers. For each integer, it checks if it divides both input numbers. If it does, it is a candidate for the GCD. The last such integer encountered is the final GCD. Determine the smaller number. Identify the smaller of the two input integers. Step 2 is the iterate through integers. Start from 1 and iterate through the consecutive integers up to the smaller number. Check divisibility. For each integer, check if it divides both input numbers without leaving a remainder. Step 4. Store a candidate GCD. If an integer divides both input numbers, store it as a current candidate for the GCD. Step 5. Return the final GCD. The last integer that satisfies the divisibility condition is the final GCD. Advantages of the consecutive checking algorithm. The consecutive checking algorithm offers several advantages: simplicity, ease of implementation, and applicability to a wide range of input numbers. Simple and intuitive. The logic of the algorithm is straightforward and easy to understand, easy to implement. The algorithm can be easily coded in any programming language requiring minimal lines of code. Wide applicability. It can be used to find the GCD of any two integers, regardless of their size or complexity. Time complexity analysis of the algorithm. The time complexity of the consecutive checking algorithm is 0 of minimum a, b. Where a and b are the two input integers. This means the number of operations required by the algorithm moves linearly with the smaller of the two input numbers. Input size, number of operations. For small size, the number of operations are only few, and for the large size, the number of operations are many. Practical applications of the consecutive checking algorithm. The consecutive checking algorithm finds practical applications in various fields, including computer science, cryptography, and number theory. It is used in tasks such as simplifying fractions, finding the least common multiples, that is LCM, and performing model arithmetic operations. Simplifying fractions. The GCD is used to reduce fractions to their simplest form. Finding the LCM. The GCD can be used to calculate the LCM of two numbers. Model arithmetic. The GCD is employed in various operations involving model arithmetic. Comparison with other GCD algorithms. While the consecutive checking algorithm is simple, there are more efficient algorithms such as the Euclidean algorithm, which has a logarithmic time complexity. However, the consecutive checking algorithm is still a valid and useful method for smaller input numbers. Consecutive checking, simple, easy to implement, linear time complexity. Euclidean algorithm is more efficient, logarithmic time complexity, suitable for large numbers. Here is the conclusion and key takeaways. The consecutive checking algorithm is a basic but valuable method for finding the GCD of two integers. While it has a linear complexity, it is simple to understand and implement for smaller input numbers. It is a practical and efficient approach. Simple and intuitive, the algorithm's logic is easy to grasp. Easy implementation, it can be coded with minimal effort. Useful for smaller numbers. Practical for finding GCDs of smaller integers. Thank you for watching this video.